Okay, our last section in chapter 10 is going to be 10.8, graphing polar equations. And we're just going to make a table of values as we have in the past. So begin with our angles, 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Let's stop there. We're running out of room, but we'll see we don't need to go any further. So if you will run those through your calculator real quick and get the R values. If you're going to do that with 3 cosine of theta, then make sure you're in radian mode if you use these, or degree mode if you change them to degrees. Okay. All right, so we should get 3, and then pi over 6 would be 3 square root 3 over 2, which I know from my calculator is around 2.6. Pi over 4 is 3 square root 2 over 2, which from my calculator is around 2.1. Pi over 3 is a half times 3, 1.5. Pi over 2 is 0. 2 pi over 3 would just be negative 1.5. And then 3 pi over 4 is negative 2.1, and then a negative 2.6, and then negative 3. So let's see. We have 0, 3, pi over 6, and then it goes to 2.6. So these are in halves, so 2.6 will be right around there. And then pi over 4 is 2.1, so just a little bit more than 2. And then pi over 3 is 1.5, so there's 1.5 is this third one. And then 0. And I think you can kind of see what it's making. If we go to 2 pi over 3, it is negative 1.5, which means we drop into this quadrant, the fourth quadrant. Okay, and then negative 2.1 for the next one. So that'll be over here in this quadrant. And then 11 pi over 6 is 2.6, so a little bit more than 2.5. And then negative 3 on, if we go backwards, we're here again. So I think you can see these points. If not, you have to do points in between. But I think you can see these points are making a lovely circle. Right. So 3 cosine of theta makes a circle. So this family is the circles. And remember, they are R equals a cosine of theta, or the alternative, R equals a sine of theta, is also a circle. It just has a slightly different symmetry. And these are the quick symmetries. Your cosine graphs are going to have polar axis symmetry. That is, they are symmetric with respect to the polar axis. And sine graphs generally have symmetry with theta equals pi over 2, or in the rectangular, what we like to call the y-axis. So sine graphs will be symmetric generally with the y-axis. All right, so now let's use our quick symmetry, and R equals 1 minus 2 sine of theta to come up with a nice equation, or a nice graph for this equation. So if we look, the quick symmetry, it's sine, so it's going to be symmetric with the line pi over 2 right there. So if you're symmetric with that line, let's choose some values that are going to be symmetric. We only need one side of it. So, I mean, we can do 0 and pi over 6 and pi over 4, and pi over 3, and pi over 2. But then you really don't want to go into the second quadrant, so maybe we should choose some down here in the fourth quadrant, like 3 pi over 2, 5 pi over 3, 11 pi over 6, and then we'd be back at 0. Okay, so let's try these. Remember, our equation is 1 minus 2 sine theta. So we plug in 0, and that's going to give us 1 minus. So you all plug them into your calculator and get your table. And I got this. 0 will be 1. Pi over 6. Is not right. Oh, 1 minus 2 sine theta, that'll be a half, so 0. All right, and then for pi over 4, we get negative 0.4. For pi over 3, we're going to get negative 0.7. For pi over 2, that's going to be 1. 1 minus 2 is negative 1. All right, and then 3 pi over 2, that would be a negative 1. So it would be 1 plus 2, so that one's 3. 5 pi over 3 is going to give us, oh, I forgot the pi over 4 again. Going to give us 2.7, and then 11 pi over 6 is going to give us 2. All right, because that'll be 1 plus 1. All right, let's see how that's going to look. At 0, we're at 1. So 1 is 2 of those. At pi over 6, we're back at 0. At pi over 4, we're at negative almost a half, so right there. At pi over 3, we're back here at negative 0.7, so right around there. At pi over 2, we're at negative 1, so we've hit here. At 3 pi over 2, we're at 3. 1, 2, 3. At 5 pi over 3, we're at 2 and 2.7, so right about there. And at 11 pi over 6, we are down at 2. So I don't know if you can see this really well, but it kind of looks like it's making a treble clef. Do you see how it's kind of wee like that? Well, the other side, we'll do the other half of that, and it'll look exactly the same. All right, so what we do is we just simply connect those. And then we make, let me see, that's there. So make it wide enough. And then this one will be over here. And this one will be here. So you can kind of just know that they're symmetric. And then you have this lovely graph. All right, this one is, the name of the family is Limousin. And it's that weird French C that sounds like an S. And this one is with an inner loop because of the relationship between the 1 and the 2. All right. So that's the family. Zeros, maximums that you will need. Also, you can find the zeros and the maximums, and that will help you to graph more quickly. Okay, so remember, a polar graph is going to reach its maximum when sine or cosine becomes 1 or -1, depending on whether or not it's a plus or a minus. You just have to think about which one's going to be the maximum. Like our last one, the maximum was 3 because it was 1 minus 2 sine theta instead of 1 plus 2 sine theta. And r, for zeros, you just make r equals 0 and solve. So let's look at the zeros and the maximums for the polar equation. R equals 5 cosine 2 theta. All right, so when is this going to be a maximum? Well, it's going to be a maximum when the cosine of 2 theta is its biggest, and its biggest is 1. So when is cosine equal to 1? Well, that's when 2 theta equals, remember this is a double angle, so we're going to have to multiple angles. So cosine is 1 at 0, and then keep going, 2 pi. Then we divide by 2, and we get theta equals 0 and pi for the maximum values. Then if we set r equal to 0, we can find the 0. 0 equals 5 cosine of 2 theta. And that's going to happen when cosine of 2 theta equals 0. And that's when 2 theta equals, okay, well, when is cosine 0? Well, at pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2. So remember, we have to go twice. Instead of 0 to 2 pi, we have to go 0 to 4 pi. Then divide by 2, so we get 7 pi over 4, 5 pi over 4, 3 pi over 4, and pi over 4 as our 4 angles that will produce a 0 for theta. All right.